Okay, so I did some off-camera changes to the Vec3 class. I added a bunch of notice cards. And I did just add a unary plus and minus operator in here, so yeah, some minor changes. Anyway, we're on to the next part of creating the stores for the particles, because you can't have n-body simulations without particles for the interactions. Okay, what should I call this? Particle store. Amazing. Now, we are not making individual particles here. Yeah, we're not making individual particle classes because, like, that's an AOS. AOS is kind of bad for simmed. So, yeah, we're gonna make it an SOA, which is much better for simmed stuff to make things faster. Not center vector. I'll go old school here to keep some invariants slightly better. Okay, yes, I'm just gonna use raw pointers. Terrible idea, I know, but this will make life a bit easier, and it'll stop like problems with discontinuity between the arrays, since that's a problem with standard vectors. So vec3 cycle positions, vec3 velocities, vec3 accelerations. Okay, what else do we need here? Oh yeah, an array of like masses, yes. Oh yeah, and I'm going to actually do something interesting here. We're going to yeah, I'm just gonna store an index beyond which we're going to store test masses, kind of like rebound. So I'm just gonna implement. Do I have size T? I do. Okay. And no, I'll only split this entire header file if this thing gets too long. It's not long yet. It's only 79 lines. So N. Okay, I should probably make this a class because, yeah, I don't want to see how. So public, private. Yes, I do private first. Don't complain. Don't cancel me. Size TN. Okay, so I should also make we will need a few more of these as we continue with more integrators. For now, we're just doing leapfrog. Basically, it's the simplest integrator. So for now, that's what we're starting with. Yes, I know this positions someone can just spontaneously change this. Do I feel like doing that? Yes, I should probably make all this private, but like for extensibility, general extensibility, it might not be good for that. So I'm just gonna rely on the good old method of I hope the user isn't stupid. Okay, what do we do? Particle store. In fact, I should probably make all of these null pointer. And this guy 0. Okay, I think this is good. So, particle store equals default. Yes, I know. Someone guy could here just say like, some guy outside of this class could just say like, you know, yeah, let's just make this private. I'll figure out a way to make this extensible later. Next, particle store, but with an n amount of elements. So size tn trailing underscore. So you do n underscore and then this. So now we have positions. What new vec3n, I think that's it. Velocities, new vec3n. Accelerations, new vec3n. Masses, new vec3n. Not vec3, sorry, double. So what do you want? Oh yeah, why did I type that? I just mentioned that's kind of stupid, but anyway. Now that we're here, I should probably push this down a bit, because I'm not, yeah, this is getting a bit. Okay, that's a bit better. Better for readability. Do we need to do anything else in here? No, I don't think so. Okay, so obviously since we have this manually managing memory, because just using standard vectors here would make it way too easy to disconnect them and keep them off, because otherwise you end up with stuff like you could just append something to positions without doing it to the rest of the vectors, and then yeah, you're gonna have a mess. So tilde particle store, you need to destroy all of these as usual. Delete positions. Delete velocities. Delete accelerations. And delete masses. Okay, yep, that looks good as far as destructor, but because this is the rule of 5, you're gonna need a copy constructor, assignment operator, and a copy assignment and move assignment. So particle store. No, not do these. Do constructors first. So const particle store. Other, that's what I usually do. n other dot n. Okay, so here we just, I think we allocate n as is usual. So yeah, I'm just gonna add, oh look, it decided that it was going to go in a single line again. Beautiful. Oh well. Well, I guess the other guys can just new vec3 and velocities, new vec3 and not screwing this up. Accelerations, new vec3 and no, why did I type that? Okay, I'm just gonna take forever. Tab. And then what were the masses? New double N. So we're just gonna allocate them in the initializer list. Yes. Like I'm just gonna get rid of the Copilot screen. Okay, so we're gonna have to go. Should we mem copy? Yeah, we should probably think we could just use mem copy. No one will notice if I just include it in here. Ah, yes. I obviously want to include my Clang format in here. Anyway. Why am I having a brain fart? Okay, I think it's C standard lib. Yeah, I'm gonna do C standard lib. I think that's it. If I do standard mem copy, I think so. Destination source n. Yes, okay. So the destination is positions. Source is other dot positions. And I think n. What's n? Yeah, just straight up n. I think that's it. What do you want, mem copy? Oh my god. Oh, C standard lib does not provide mem copy. What provides mem copy? C string. Why? Anyway, standard mem copy velocities, other dot velocities, and standard mem copy accelerations, other dot accelerations, and standard mem copy masses, other dot masses, and again, modern C++ would hate this, but yeah, this is for safety reasons. No, not memory safety, like API safety. But wait, if I'm doing this, it's private anyways. Why the am I using this? Why am I being... Well, I'm too deep in the rabbit hole, so... I guess pretty much probably better to just replace size T, and I'm gonna keep N, but standard vector vec3. And of course I have to include vector. Okay. Please don't confuse standard vector with the vector I have up there. Okay. Standard vector velocities. And then standard vector double masses. And I don't need all this right now. And I don't need a copy constructor, and I don't need this. Okay. Okay, so this is much better. I'm just gonna now add some index. I should probably now make a particle store handle and particle handle because convenience. Class particle. I'm also just gonna do friend class particle real quick. Okay. What do we want? So we're going to want a pointer to a particle store, so private particle store PS equals null pointer. And then we need an index, I believe. Size t index. I'm just gonna collect IDX. I'll say that's 0. Public. Particle store equals delete. We're gonna delete the oh, I can't do that. Oh, okay. Oh, yeah, I forgot to just making another constructor that's not one of the special ones implicitly deletes that. So there we go. So particle store PS and then an index, like, and of course I'm just gonna trail these since I do not feel like screwing up these variable names until these classes get too large. So PS, and since that's actually a pointer, not a reference, I'm going to have to explicitly take the address of it. So PS and then index. Yeah, that's just normal. Okay, I'm not gonna provide an API for creating one from here, so I'm instead just going to do this. Yeah, I'm not gonna bother doing that because, like, it's semantically different. Very. Yes, okay, so if we try to just, PS. Yeah. PS just because particle store. Yes. Okay, so I'm just going to obtain... I'm going to get some member functions in here, like... position, get the position, velocity, and so on. Or rather, references to those. So... vec3 pause. Return PS... positions, I think, yeah. Positions, why am I'm having brain fart right now. It's vec3 val, very similar thing, but with velocities. Acceleration. Okay, and then mass, so double oh wait, as for mass and mass, I think there's going to be some, yeah, okay, this should be fine because, yeah, I knew there'd be some sort of like, after this index, it's all test particle stuff. Yeah, that's going to cause some weird stuff with particle, but I'm just going to avoid all those problems by saying, if you're appending stuff, maybe don't, like, keep using a previous one. That's not guaranteed to do anything good. It might do something bad. I'm just gonna use that excuse. Listen here, I'm not doing that. Okay, mass. Return PS masses index. Yeah, I think that's it for now. Now it's for these. Okay, for these, let me check. This guy might want that append, so void append. Yes, I forgot I'm still in the header. I probably need to make an implementation file eventually. Void append. Void, yeah, I'm not even gonna do like append here. I'm just gonna call it add particle. Yes. Oh yeah, and if you're wondering why my style is weird, is not normal. Yeah, first off, I prefer state case, and second of all, I made an entire client tidy for that. So, do not sue me for not using camel case or Pascal case functions. Like, the only Pascal case I accept is for types. Add particle, void remove particle. Oh yeah, should probably give these IDs too. Yeah, Rebound has it and they're pretty useful, so UN64T IDs. UN64T ID. Return PS IDs index. That looks good. And I'm going to make a const reference for this. Sorry, that was a minor mistype. I'm doing these. Why? Y P Control X. I hate it. Okay, now const particle. Okay. Okay, why are you crashing out again? Const, I'm just gonna do. This can be a const reference now. Not sure what kind of drugs this thing is smoking, what Clang D is smoking here, but I do not understand its errors. Are you out of your mind, Clang D? Let's see if restarting it works. No, something is very wrong and I do not know what. Wait, is nothing closed over here? I'm gonna test out the maze on this. Okay, so const. Why are we doing this actually? Since they're const ref, you may as well just copy them, and these are tiny types, so it doesn't really matter. Vec3, double UN64T. Friend class particle. Can I put multiple in there? Bro, I can't do that. That's like a C++ 26. Annoying. This is again a C++ 17 library. So do not look at ask for C++ 20 specific things or anything past that. So yeah, this is gonna get painful. You know what? Are you going to even compile? Is Clang D just having a fart and the compiler is actually fine with it? What are your errors again? Particle. Okay, I think I figured out the error. I was just being stupid. I forgot to change the constructor name. This is why I hate constructors. Why? Why do I have to copy the name? So now all is well in the world, or it should be. I'm gonna test this. Yep, it's working. Building. Okay, that's good. You're gonna add particle, remove particle. Where am I using C string? Because what headers can I remove without anything complaining? I obviously need. Do I need C string? No, I don't. Do I need the standard lib? No, I don't. Okay. Okay, making sure. Right, now that that's dealt with, I'm gonna have to create a new folder now, so. Source. And we're immediately just going to make, like, particle.cpp. Hashtag include FreshNBody.hpp. And I'm just gonna make it shut up with. I'm going to nuke it. Let's see if a nuking did the job. No. Okay, something's weird. Why is this? I probably will make some proper unit tests later. I did just install gtest, but anyway, we nuke this real good. Nuking method. Is there even a no? I hate that it just can't. Clang D can't detect stuff in build tier, but only in build. Okay, is dot clang D in the get ignore? No. Okay, I'm gonna add this. Clang D and dot clang D. My own personal by other projects here. I'm just gonna grab this. And now if I restart the language server, okay, now it works. Okay, good. Namespace FNB. So particles. Yeah, we're just gonna have to particle. What? No, not particle. Sorry, particle store. Add particle. And then I'm just gonna do class ind particles. Ind particle, which is a struct ind particle, which is very basic. It's just a vec3 pack, except it doesn't actually. It's an independent thing that I'm not actually using only for convenience. For the API. Internally, we're not using it at all, ever. Actually, it might be for like one-offs, but not really. Pause. Vec3 vel. Vec3 ac. Vec3 mass. Not vec3 mass. 99% of this stuff is vec3, so I'm not bull. Double. And then UN64T ID. Yeah, okay, that looks good now. So now if I do an ind particle, I'm gonna actually construct this guy. Doesn't matter. P const in particle P. Oh yeah, why do I keep dropping that? There we go. Yep, good. P, and now does P have? I forgot. Why do I forget? But anyway, pause. So positions dot push back P dot pause. velocities dot pushback p dot val, accelerations dot pushback p dot ac, and masses dot pushback p dot mass. IDs dot pushback p dot id. I think that's it. Oh yeah, and I forgot we do need to toss in some not ID, sorry. N plus n. Here I'm also just gonna here I'm going to return a particle. Yeah, in the particles. Okay, now if I do void add particle and then const standard vector keys, and I'm just gonna void particle store add particle const standard vector in particle piece, and then okay, yeah, so now here we just do n plus equals piece dot size, and then for const auto p piece add particle p. Or you could probably one-line this real quick. Convenience. Remove particle. Okay, I'm not sure what to do with removing particles, but yeah, okay, so you should particle, I should probably get an index. And the same pattern where I'm just gonna standard vector in particle remove particles, and then const standard vectors, not size t. Yeah, size t actually, yeah, size t. Size t the indexes I still haven't added an operator. Particle operator. And just class particle. Yeah, this looks good. size the index. I hate circular dependencies. I just hate this. Okay, I think I'm gonna have to define this in the header, despite this being like the most trivial task in the world. And then if I do in here, class const particle, operator const. Okay. Yeah, here I should probably define a conversion. And then const particle operator const particle. Return particle with this and an index which is given in the thing. Similar thing with const particle store. Size the index, return particle, this index. Oh yeah, I forgot about the const here. Alright, const particle. Again, this looks accurate now. Now we need the conversion operator to const particle. Okay, why am I being stupid? I think I can literally just define these in the header, and these are very trivial, so don't feel. Okay, so now that this is shrunk down significantly, now that this is now we do need to define this operator const particle, so this particle yeah, so we're just gonna convert it as usual. Convert it. So return const particle ps and index. Okay, yeah, okay, this looks good. Sorry if this is taking forever. Anyway, now that we have these guys in the trivial ones, particle store, we're gonna store particles, so remove these two are the final ones I'm gonna work on, so in particle store, remove particle, size the index, index. We're gonna use a swap and pop. Like usual, we're gonna do a swap and pop. So let's see, standard swap. Let's see, do we have swap? Yeah, I think we do a swap. So yeah, positions index. Returns reference. Very descriptive as to what this thing returns. Oh yeah, I just returned a reference. That's good. So yeah, and then positions index. Standard swap velocity. I'm just gonna do this here. Wait, this is going. Yeah, I'm just gonna make this like put it in an empty namespace. Void swap and pop. Template type name T. Standard vector TA V, and then size T index. Now just standard swap and positions V dot back. V dot back with V index. Positions index. Velocities index. Accelerations index. Masses index. IDs index. Okay, now that we have done this real quick, now that we have swap these real quick. Swap last, yes. Okay, so that's good. Last. Swap last. Swap last. Swap last. Swap last. Okay, I'm going to now have to pop it. That's swap and pop. This is an O1 operation because normal vector erasure is very slow in the middle. It's only really efficient at the end. So positions, I'm just gonna do in particle res and designated initializer is controversial, I know, but pos is equal to positions dot back dot vel equals velocities dot back equals accelerations dot back dot mass equals masses dot back id equals ids dot back. Okay, so now that this has been done, now we can pop it. Yay. Pop it. So now that the res has been done, we're now gonna do positions dot pop back, velocities dot pop back, accelerations dot pop back, masses dot pop back, ids dot pop back, and finally I can return res. I'm gonna separate these like that. And now the one for multiple, so which is a standard vector in particle store, remove particles, const standard vector in particle idx's. And now we're just gonna do this repeatedly, but to keep stability with indexes and to make an intended user, we're going to use a backwards sort. You're gonna get the last one deleted beforehand. Pop. So do I have a place to explain? Do I? I don't know. Let me think through this. So if we have a so if we have a vector like this, a particle store like this, we're all gonna assume that they're the same size because that's an invariant, that if it's broken, something is very wrong. I'm just gonna do this real quick. I don't feel like accurate here. In fact, it's probably faster. Just do this real quick. Okay, so we have this vector. So we have, say we want to delete, how many elements there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12. So say we want to delete indexes 11, 9, 8, and 6, for example. Yeah, maybe add like 4 here. Yes. Okay, so we're going to swap and pop would send this to the end, or rather, this gets swapped with this. Then this is gonna get deleted. Okay, so now this is gone. So now 11's gone, basically. There's still an index 11. It's just no longer the original 11th. 9. Now 9 is going to get deleted by having this get swapped with the last one again, which has been updated. Then 8 and 7. Yeah, it's going to be stable. Okay, so we're going to now implement that. We can do that with a standard set. Wait, standard set, is that a proper choice? Yeah, it actually is. It just... Why did he put in particles here? These are size T. Include set. Standard set S ADX's dot begin is dot end. Okay, I think yeah, this is shocking. I know this. And now I'm going to make it reverse iterators here. That's very rare for those to occur, but auto it is equal to s dot r begin. It not equal to s dot r end plus it. Plus it, and then we then append this to another standard vector. We append this in particles to another standard vector, which is res. Again, I'm not creative. Res dot push back, remove particle it. And then you just return res. Is this it? I think so. I'm going to check in with CodeRabbit if I did some stupidity here. Where are you, CodeRabbit? Thank you. And we wait. Entertaining. I'm probably gonna cut this. Okay, he's done, and I already found a bunch of errors. Okay. Error 1. Okay, this one was kind of painfully obvious, but yeah, probably shouldn't. Probably should just. I'm just gonna do. Yeah, that was kind of a terrible idea. I'm just gonna do this real quick. So. In fact, I'm just gonna yank this whole thing here. Wait a sec. P, and I just do this. Okay, that's done. Okay, this add particle. Why they put it add particle? It's add particles anyway. Add particles. Okay, I just fixed that real quick, and then do on FreshNBody dot. Missing function definitions will cause linker errors. Bro, I'm defining them in here, but anyway. You did not in any context, CodeRabbit, but anyway. No bounds checking. I don't feel like doing bounds checks. This is performance code. I don't feel like doing bounds checks. Missing inline. Where are you? Missing inline. Oh. I thought it did that automatically outside. It doesn't, apparently. Okay. Okay, so that's done. Goal, so vector passed by value. Oh, wait, why did I not constref this? Yeah, but okay, why? Well, not constref, but why didn't I ref that? N is double counted, missing minus n decrement. Okay, makes sense actually. Minus n. And then this will eventually. Yeah, I'm probably just gonna do another yank. I'm probably just gonna yank this again. So. Go back into normal mode. Y, P, and then P. I'm gonna do size t is equal to this. P and then res dot push back P. And then S minus equals. Not N, sorry. N minus equals. Size. Okay, let me test this. Okay, let's do another review, check if I fixed this. Again, more editing. Okay, Mr. Code Rabbit. Okay, well, this is. Have you seen the Logan's? I don't remember the Rust guy's name, but this is bad. I'm telling you that this is bad. Yeah, this is bad, but I'm not adding that. I'm not adding that, but yeah, that is actually a good idea to push to the end. Drop that wherever you are. Okay. I'm gonna cut and paste this real quick. Oh, so you want me to use S? Actually, that makes sense. I'm just gonna use S. Okay, I think this is ready now. I should probably build this now, test it out. Okay, I should probably now get some source files. So source files equals src/particle.cpp And I should probably do sources. Source files plus that. There shouldn't be any external dependencies for this, but I'm gonna test. Okay, did it actually? Yeah, it actually built. Okay, that's good. Now I'll commit this now. So git add dot and git commit at m. Added a particle system. Add a particle API. Yeah, next time we're gonna do a simulation and integration API. And then after that, begin work on actual integration code. So, be soon for that. Been pushed. You know what? I should probably also change the name of the repo here also. Yeah, and I'm doing quite a bit today, so. I'm gonna go here, settings. Rename this to FreshNBody. Again, I should probably change my git remote set URL https://github.com/rvlacl16bit /FreshNBody. How do I do this? How to change remote location on GitHub. Oh, set URL origin. I forgot the origin. It works now, I think. Okay, so be on here for the next one where we will implement the simulation class this time. Bye.